Okay, so we're going to see additional ways of approaching this integral problem. The first thing we're going to learn is the midpoint rule, or another thing we're going to learn is the midpoint rule. And this approximates the area. So the midpoint rule just approximates it. It doesn't give us the exact area. And so because it just approximates it, because it's not the exact, we're not going to take the limit. So no limit is involved since it's not the exact area. So we're not going to look at a million infinitely many rectangles. They're going to tell us how many rectangles to look at. So this is what the midpoint says. So we can have this definite integral. So again, it's the area of the region from A to B under the curve F. And it's approximated. This is the midpoint rule. So we have our squiggles for approximating. And we're going to take the sum from 1 to n. So again, n many triangles. And again, we're going to do the area of those. I said triangles, I meant rectangles. We're going to do the area of the rectangles, so the height. I'll explain that symbol in a second, times the width. Okay? And this one in particular, x bar sub I, is the midpoint, okay, of the ith interval. So to find the midpoint, you add up the two endpoints and you divide by 2. Okay, and that's the midpoint. That's our midpoint formula. So this is the midpoint of the ith rectangle. And the ith rectangle is defined by this interval. Okay? All right. So let's look at an example. And we're going to number 12. And of course, you know, the question is, when would we use this? How will we know when to use the midpoint? And we would use it because it tells us to. So for instance, the instructions on number 12, it says use the midpoint rule. So again, instructions are important. They tell us how many rectangles we have, and we're going to use that many rectangles to approximate the integral. Okay, and number 12 is this function. We're going from 0 to pi of x sine squared x dx. Okay, and they want us to use 4. N equals 4. Okay, so we're going to use the midpoint formula. We know what our function is. We know what n is. So I'll just write I equals 1 to 4 since n is 4. So we have to figure out the midpoints and we have to figure out delta x. Okay, and delta x is the length of the rectangles. So if we are having, you know, an xy plane, we're going 0 to pi, and we want 4 rectangles, we know we have to evenly divide that into 4 pieces. So, you know, sometimes we can do it just by looking. Like this, we can just divide in half, or we also have our formula, right? B minus A, pi minus 0, divided by 4, okay? So delta x is 4. And then we have to go through and we have to find each midpoint. Now this one's not so bad because, you know, it's one of the endpoints is 0. So we can just take the pi over 2 and divide it in half. So that's not so bad. But if it was a little bit more challenging, for instance, if we wanted to find the midpoint here, remember what we'd have to do. We'd have to look at 3 pi over 4 plus pi over 2 divided by 2. All right, so we need the same denominator. So multiply top and bottom by 2. So 2 pi over 4. Okay, so then this is 5 pi over 4 divided by 2. Clean that up, it'd be 5 pi over 8. So that would be this midpoint right here, 5 pi over 8. Okay, a shortcut, once we know one midpoint, because everything is separated by pi over 4, we can just keep adding pi over 4, add pi over 4, add pi over 4, until we have all our midpoints. Okay, and I'm just going to multiply top and bottom. So I get in terms of 8, so now pi over 8 plus 2 pi over 8 is 3 pi over 8. 3 plus 2 is 5. 5 plus 2 is 7 pi over 8. All right, so we have two different ways of getting our midpoints, right? We can do it from scratch each time, like we did here, or once we have one midpoint, we can just add delta x to get the remainder midpoints. All right, so we're going to be using the midpoint to determine the height of the rectangle. Okay, so again, whatever the function is, I don't know what it is, I'm just guessing. We're going to use that height to determine, or that function value to determine the height of that ith rectangle. Okay, so that's the midpoint formula, and it's an approximation. Okay, so something like that. So what's that going to look like? Well, we can definitely use what we have here as a visual, or we can also go back to this and expand this out 1 through 4 times. So let's write out our complete thought. So the integral from a to b of f of x dx is approximated by, okay, so the height of the first midpoint times delta x, which is pi over 4. All right, so that's that first area. And then to add the second area, it's the height at 3 pi over 8 times the base of the rectangle, which is pi over 4. And we do it for the third. And the fourth. Okay, so that is our midpoint formula. Now we have to clean it up. We actually have to evaluate it. So one thing I'm going to do, so my complications are a little bit more simple. Notice we have the pi over 4 factor in all of our terms. So what does that tell us? We can factor it out. Okay, so now I'm just going to plug in pi over 8, 3 pi over 8, et cetera, into this function, x sine squared x. All right, so f of pi over 8 is x sine squared x. And then x. All right, and then x for the second expression, 3 pi over 8 sine squared x. And then the third rectangle, x is 5 pi over 8, so x sine squared x. And the fourth rectangle, x is 7 pi, the midpoint is 7 pi over 8, so x sine squared x. All right, so there you go. And then remember that pi over 4 is on the outside. This is something that we just throw in our calculator and we get an approximation, and via calc, because we don't know, we only know signs for, the multiples of pi over 4 and pi over 6, not pi over 8. So we have to do it via calculator, make sure you're in radian mode, and we should get approximately 2.4674. All right, that was also part of the instructions. They wanted us to round to 4 decimals. So there you go. That's us using our midpoint rule. So we can also approximate it as well. We didn't have to take the limit. We just had to look at the area of triangles, or my goodness, of rectangles. Okay, so more stuff in this section. This is a big section. We're going to be looking at properties of definite intervals.